This is the solution video for numbers 91 through 106 of the Keystone review packet. So we start with interquartile range, and the rest of this packet is going to be on central tendency. So you're going to see a lot of these kinds of questions. So with interquartile range, it's basically like you're making a box and whisker plot. You'll need to start from the lowest number and make them go in order from least to greatest. So it looks like 398, and then 421, 442, 464, 486, 505, and 524. Listed from least to greatest. So interquartile range is the range between the quartiles, so we have to do a little bit of work to find those. So first off, you always start with the median then. 1, 2, 3, 4, 5, 6, 7 numbers, so the median is this number, 464. And then the interquartile range, the quartiles are found by the first quartile is the median of the lower half, which is 421, and the third quartile is the median of the upper half, 505. So really what we're saying is the interquartile range runs from 421 to 505 between the quartiles. So 505 minus 421 is 84. So you don't actually have to go the whole way through making a box and whisker plot, but you're doing the procedure as if you were to find the interquartile range. Alright, number 92 says the line plot below shows the number of hours each student is in Miss Smith's class exercise each week. What is the median of the data in the graph? Okay, so when you see this, what it's called is a frequency table. So each X represents how many times that number showed up. So really what we have are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So there are actually 20 numbers here. Right? We could write them all out, but I don't think we're going to need to do that, because it means that the median would be between the first 10 and the other 10. So, you know, like we need the first 10 numbers, and our median will fall right in between them. So let's count the first 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th number here would be 3, which would mean the 11th number is 4. So the median is right in between at 3.5. So our answer for this one would be D. Alright, I think the rest of this is going to be about reading graphs. So this one says the company made a bar graph showing the amount of sales for each month in thousands of dollars, which is the closest to the mean amount of sales for the 4-month period. Okay, so a mean is an average. So this one is, it says 5.5, but that means 5,500. This one is 9,000. This one is 5,500 again, and August is 8,000. So if we want an average, we would just take those 4 numbers and add them together, and then divide it by 4. You should get an average of 7,000. This is 28,000. And then divide it by 4, 7,000. Number 94 says the graph below shows the results of analysis of a group of 18 male students. Their height measured in inches and self-esteem is measured by taking the average of the students' responses on a survey, where 1 is the lowest self-esteem and 10 is the highest. Okay. So based on the chart, it says, as an individual's height increases, self-esteem decreases. Okay, well, let's take a look at it this way. You can see the data generally goes upward like this. which means if you drew a best fit line, it might be somewhere in here. So it's clearly upward. So as the height goes this way, if the height goes up, what happens to the self-esteem? You can tell that it goes upward. So we're saying if the height increases, the self-esteem increases. So which one of these says that? It says an individual's height increases, self-esteem decreases. No good. B, there is no relationship between an individual's height and self-esteem. Well, we kind of have one. It says an individual's height decreases, self-esteem increases. No good. An individual's height increases and self-esteem increases. That's it. So our answer for that one was D. Just reading what the data shows on the graph. Alright, you're going to have a lot of box and whisker plots and so on this test. So when we do this one, it's important to be able to read these things in a whole lot of different ways. So this one says the number of CD sales for a new musical group over a 6-month period are represented by the box plot below. Which set of data below represents the median and the third quartile in that order? Okay, the median is the number or the line that's drawn inside the box. So the median for this one is 70. So that eliminates A and B. And then the third quartile is the right edge of the box, which looks like it's somewhere around 80. So it looks like our answer is D. So this would be the first quartile, the median, and the third quartile. This one says, what is the range of the data shown in the stem and leaf plot above? Okay, so the stem and leaf plot, it starts off with 749 and then the leaf part is 3, so that number is really 7,493. And then the highest number it gets is 753, but to an 8, so it goes up to 7538. So if you want a range of those numbers, you would take the bigger one minus the smaller one, you should get 45. Okay, this one says the following stem and leaf plot shows mass scores, and it wants to know what is the mode. Mode's the most frequently occurring number. So if we look through this, we're looking for a lot of repeats. Like here I see this is 66 twice, 72 twice. It looks like right here I see 3 3s in a row, and that's the only one that shows up 3 times. These 3 3s go with this 8. It's 83. So we're back to reading a graph again. Wants to know what is the equation for the line of best fit. Okay, so this one is just in dollars, so we can read those normally. This one is in hundreds, so each one of these is actually 100, 200, 300, and so on. So we'll have to be aware of that when we count. So the first thing I noticed is that the best fit line starts right there with a y-intercept equal to 40, which means on the end it should say plus 40. So I know that B is incorrect, and D, there's definitely a line of best fit. Well, let's leave that one just in case. Alright, so then if we count rise over run, we find another point right here. It would be down 4 and right 2, but remember when we go right 2, we're not going 2, we're going 200. So this is down 4 and right 200. If we reduce that, it's negative 1 over 50. So our equation should be negative 1 over 50x plus 40, which means the answer is C. Alright, so for number 99, it says she planted a farm on a tree in 1920, and she measured the tree trunk's diameter every 10 years and showed the measurement. The scatter plot below shows the progress of the diameter. The year 1930 is equivalent to 10 on the graph. So maybe it's not a bad idea to mark these as you know, 1930, 1940, and so on. So this is 1930, 40, 50, 60, 70, 80, 90, the year 2000, and this one would be 2010. So it says, looking at the line of best fit equation shown, which is right here, what will be the approximate diameter of the tree in 2010? Okay, so what we need to know is what number should we put in for x to figure that out. Well, remember, it's the number of years past 1920 that we need. So we're in 2010, and that would be the same as 90 years past 1920. So x would be 90 for our problem. So we would do y equals 0.507 times 90 plus 5.543, and just calculate out an answer. You get 51.173 inches. We're almost done. We're on to number 100. So this one says, which scatter plot most likely has a line of best fit represented by y equals 2x plus 1? Okay, so the first thing you'd want to do is go to each graph and kind of look at the data and see what you have. This graph shows data going downhill like this. I would say that that can't be represented by that equation because that equation has a positive slope. So this is no good because we need a positive slope. So looking at the next one, it has uphill data. So that could be it. So we'll hold on to that for a second. If you go to this one, it has downhill data, which is no good. So we need a positive slope. So it's either x or y. So if you draw a best fit line here, a line through the middle of where we drew that in, I think you can see that this one is closer to having a y-intercept around 1 and going up 2 and over 1 than this one is. See what I mean? This slope is not steep enough. This one is the correct answer. So the last part of this lesson is on probability. Probability is probably one of the easier things you'll calculate on here. So it says a number cubed with size labeled 1 through 6 is rolled 2 times, and the sum of the numbers that end face up is calculated. What's the probability the sum of the numbers is 3? Okay, well, if you think about it, right, if you roll a die 6 times, or excuse me, if you roll a die, it has 6 possibilities. And if you roll a second die, it also has 6 possibilities. So we would say there are 6 times 6, or 36 possible combinations. So the only question is how many possible ways are there to roll a 3? Well, the first die could be a 1, and the second one could be a 2. So we'd have that. Or the first die could be a 2, and the second one could be a 1. But that's it. There are no other ways to roll a 3. So really we have 2 ways out of the 36 possible. If we reduce, it's 1 out of 18. Okay, number 102 is talking about a multiple choice history test. It says he decided to randomly guess on the first 2 questions. On each question there are 4 answer choices. What's the probability that he answers the first question correctly and the second question correctly? Well, again, since there's 1 out of 4 chance of getting the first one right, and we're doing multiple probability here, he would also have a 1 out of 4 chance of getting the second one right. But to get them both correctly, you would multiply straight across the top and the bottom, and you would get 1 out of 16. So he only has a 1 out of 16 chance of getting them both correct by randomly guessing. For number 103, it says that Holly's flipping a coin and pulling a marble from a bag. There are 4 white marbles, 2 blue marbles, and 5 green marbles that are all the same size in the bag. It says, what's the probability that the coin lands on heads? Well, that's 1 out of 2. And she pulls a green marble from the bag. Okay, so we need to know how many total marbles. 4, 2, and 5. That's 11 total marbles, and there are 5 green ones. So if we multiply them across, it would be 5 out of 22. That answer's A. So the only thing left are a few open-ended questions. So we'll go through those quickly and we'll see what happens. This one gives steps to simplifying the square root, and it says one of the steps shown is incorrect. Rewrite the incorrect step so that it is correct. If you're looking through this, what you'd really do with this, I would say, is maybe try to write the problem how you would write it out and see how it's different than what they did. And I think you'll find the very first step is incorrect here, because what you would want is to split this square root by multiplying, not by adding. So in this very first step, the correction should read step number 1, and it should be split by multiplication, not by addition. And then it says, using the corrected step from step 1, so now we're going to actually do it, simplify that. So 6 square root of 25 times square root of 5. That would be 6 times 5 times the square root of 5, and our answer is 30 square root of 5. So we go to number 105. It says express both the perimeter and the area of the rectangle shown in a diagram as polynomials in the simplest form. Okay, well, perimeter means to add up the distance around an object. So if we just add up all of these expressions, we have 4x's, and then if we add up the numbers, that would be 2, -2, and 6 would be +4. That's the perimeter. Just adding up each of the 4 expressions, combining all of the x's and all the regular numbers using like terms, and you would get this for a perimeter. Area is a little bit different. Area is length times width. So we would need to take this length, x plus 6, times the width, x minus 4, and multiply those together. So you want to take this x times both things in the other set of parentheses. So it would be x squared and -4x. And then you'd want to take the 6 times both things in the other set of parentheses. So it would be +6 and -24. Since it wanted it in the simplest form, you have to combine the like terms in the middle, and it'll be 2x and then a -24 in the end. This is your area. So it's a good open-ended question because it's asking you to do combining like terms for adding and then also to do multiplying. But by the time you've gotten to this point, you've done so many polynomials that this is probably a really easy one to multiply. Okay, let's go to the last one. It says Scott has $15 and he earns $6 an hour babysitting. The equation below can be used to determine how much money M Scott has after the number of hours babysitting H. So it says after how many hours of babysitting will Scott have $51? Okay, well again, M is the money here, so if you want to use that expression, and you're going to take this $51 and substitute it in for the M, and just solve it for H. Subtract the 15, and this is 51 minus 15, 36 equals 6H, and if you divide by 6, we get a final answer, H equals 6 hours. Okay, so it says Josh has $9 and he makes $8 an hour babysitting. Use the system of linear equations below to find the number of hours of babysitting at which Scott and Josh will have the same amount of money. So now we have two equations that we need to solve. But again, we're solving it for H, the number of hours. So you can look at this like a substitution. We're saying M is 6H plus 15. So if I take that and I put it in the other equation for M, it would be 6H plus 15 equals 8H plus 9. So if I subtract the 6H away from both sides, and I guess I can also subtract the 9 away, I would get 6 and 2H. And then I would just divide by 2, and H would be 3. So 3 hours. Alright guys, that's it.